Good morning, physics fans. How we doing this fine Thursday morning? Yes, it's Thursday morning. A little cloudy outside. The weatherman says it's going to rain a little bit this afternoon or this evening, but warm weather's coming in. That's a good thing. This is a changeover. It looks like some warm weather is going to be here for a while, which is hopefully all summer long. Hope things are going well for you and your family at home. Hope everything's going well for you. We are close to the end here. My plan is I'm going to do notes today and I'm going to do notes tomorrow. Sorry, I'm going to do notes on Friday, but that will be the last of the notes that we will have to do. Okay, Monday will be more of a review day. Tuesday and Wednesday will be the last chapter test that we have over chapter 10, which is Thermodynamics. It'll be the last that we will do. So once again, I will do notes tomorrow. Sorry if we're doing notes on a Friday. I know you'll be sitting there waiting for those notes to come out on Friday. But we will complete our notes this week and get our chapter test done next week. And I'm thinking about, with respect to homework, just using your evaluations that I've had at the end of the everyday notes as your homework. So if you've not been doing those and not keeping up with it, I would suggest that you do, because I'm going to utilize those as your homework grade for chapter 10. So go back and redo. You have a chances to redo the little quizzes at the end of each day of notes. Do those, and I will be utilizing those as your homework grade for chapter 10. Okay, and then next Tuesday and Wednesday we will have our last evaluation. I'll post it on Tuesday. I won't have it due until Wednesday evening, because I know some of you will be taking a calc final on Monday and Tuesday. So you will be taking that, and I want you to focus in on the calc final. And then your chapter test, or last chapter test for physics, will be on Wednesday then, or due on Wednesday evening. Today we're going to talk about cyclic processes. A cyclic process. A gas is trapped in a small metal cylinder with a movable piston and is submerged in a large vat of ice water. So the initial temperature of the gas is 0 degrees. A total of 1,200 joules of work is done by a force that slowly pushes the piston inwards. Okay, what's happening to our volume? Our volume is decreasing. We have a change of volume that's decreasing. Delta V is going to be negative because I'm pushing down on a piston. Okay, and it's shrinking the air. Temperature is remaining constant. The temperature will remain constant, and because delta V is equal to 0, work is equal to P times delta V. If delta V is less than 0, that means our work will be negative. The work will be negative. What type of process? Well, the temperature remaining constant is the clue to what's happening here, because if the temperature remains constant, what type of process is that going to be? That's going to be isothermal. So we will have an isothermal process here. Question is, how much heat is transferred between the gas and the ice water? Well, it's first off, remember, delta U is equal to Q minus W. But if my delta T is equal is not changing, since this is a isothermal process and my temperature is remaining constant, my delta T and delta U is going to equal 0. I have no change in temperature. I have no change in internal energy then. So if my delta U is equal to 0, this is equal to 0, then Q will equal W, and the amount of work will be negative 1,200 joules, which is also the amount of heat. Okay, that's the amount of heat. A total of 280 joules of work is done on a gaseous refrigerant as it goes under compression. It's going under compression, so we have a delta V again. If the internal energy of the gas increases by a negative 100 or 190 joules during the process, what's the total amount of energy transferred as heat? And then is heat removed or added? Okay, so we have work that's being done on the refrigerant. Since we are compressing, once again, work is going to be negative. Work's going to be negative because we're doing work, we're decreasing our volume. We are doing work on the refrigerant. We are compressing. Delta V is less than the value of 0, so it's negative. So my work will be negative. My internal energy of the gas is increased by 190 joules of the process. So I'm increasing my delta U. Okay, my delta U, my internal energy increases 190 joules. So my delta U is going to be a positive 190 joules. Well, remember once again, delta U is equal to Q minus W. Subbing in, we have plus 190 is equal to Q minus a negative 280. Okay, so we have to watch ourselves. We got a boom ching here. So we boom ching this, so it's a positive 280. So we're going to have to subtract off 280, subtract 280. And Q comes down to negative 90 joules. Which means that's going to be removed. Our amount of heat is negative 90 joules, so we are removing negative 90 joules of heat. So that is removed. When a gas is compressed, is internal energy increased or decreased? Well, if the gas is being compressed, once again, what's happening to the volume? The volume is decreasing. So it will be negative. It is going downwards. Our change in volume is decreasing, which means if my change in volume is decreasing, once again, work is equal to P delta V. Our work is also decreasing because we have P delta V there. So if gas is compressed, is the internal energy increasing or decreasing? This energy is eventually removed as heat. Okay, this energy is removed as heat. I'm sorry, didn't finish this here. If my delta W is less than 0, that is a negative, so my delta U is equal to Q minus a negative amount. So if my work is decreasing, I got minus a negative, which means this turns into a positive. So as the gas compressed, the internal energy is increased. My delta U will be increasing because I'm compressing my energy and my work will be a negative value. So this will be increased because I have minus a negative over here. I'm sorry about that. I sort of lost track of what I was doing. That's what happens when you get old. You start losing track. Cyclic process is a thermodynamic process of which a system returns to its original state. Same conditions as which it started. Okay, so when you have a cyclic process, you're going to go through heat, work, compression, expansion, whatever you're going to go through, and it's going to end up going back to where it originally started. And it resembles an isothermal process because in an isothermal process, once again, in an isothermal process, my delta U is equal to 0. So my net work will equal my net heat. The amount of heat going in or coming out is equal to the amount of work that's being done by or for a system. So it sort of resembles an isothermal process. The refrigeration cycle. What happens with your refrigerator? How does your refrigerator work? Sort of like an isothermal process. Remember, once a Q is equal to W, or W is equal to Q minus W, if my temperature 1 is greater than my temperature 2, which direction will the heat travel? Well, the heat will travel from warm to cold. Okay, it will always travel from warm to cold. What happens in the refrigerator? How does, once again, your refrigerator work? Low pressure, low temperature coolant flows through the walls of your refrigerator and absorbs heat until it vaporizes. Okay, you have a coolant that goes through the walls. If you put warm objects into the refrigerator, okay, it's going to look to warm the environment. Okay, it's, once again, you got an environment that's cold, you have this warm object in there, you have this cold environment you put it into, the heat starts to leave the cold environment, or the object that you put in there. Suppose you put a big 10-pound turkey in there and it's nice and warm. Well, what's going to happen is you're going to put it in the 40-degree temperature of a refrigerator. Well, the heat from the turkey is going to move into the refrigerator. Question is, what happens to that heat that goes into your refrigerator? Because your refrigerator is initially set at 40 degrees. Well, when the turkey gets put in there, the temperature of that refrigerator is going to go up to maybe 41 or 42 degrees because it's going to, the heat's going to leave the turkey and go into the refrigerator. Well, we want to keep the refrigerator at 40 degrees. There's other objects that may be in the refrigerator that will also warm. We don't want to warm our milk and spoil our milk. So what happens to that heat? Well, there's a coolant that goes through the walls of the refrigerator. Okay? That coolant will absorb the heat from the environment of the refrigerator. So you have this refrigerator here, you have the walls, and the heat will travel into the walls from the refrigerator. Once it leaves the refrigerator will then cool at that point. This coolant will absorb the heat. Well, it is a coolant, it's a liquid form. When you absorb a heat, it vaporizes. Okay, it turns into a gas. Okay, just like we add heat to water and it boils and it turns into a gas, this coolant will also do that. So my delta Q will be greater than 0, my work's going to be nothing, and my delta U will be greater than 0. Okay, because I have 0 work in here, this goes bye-bye, and this is a natural flow. This is a natural flow. As it goes, this right here, there is no work that's being done in this situation. There's no work that's being done. It is a natural flow. So it will naturally flow into that. You don't have to sit there and do any work. Okay? Think about this. It's 95 degrees and humid outside. You've been outside doing some work. You're sweating. You're really hot. okay? You go inside your house where the air conditioner's running and you just sit there. You're not doing any work. But what is happening is the water, the vapor, or the sweat is starting to vaporize and your body is starting to cool. Are you doing any work? Is anybody doing any work to cool your body down? No, they're not. They're not doing any work to do cool your body down. So this is just a natural flow. So there's no work that's going to occur with this because it's naturally going to flow from warm to cold. That is a natural thing that will occur in nature. So when we go into this coolant, it will vaporize. My Q is equal to greater than 0, my delta U is greater than 0, but my work is nothing. Vaporize, the vapor is compressed. Okay, now if we're compressing, okay, once again, when we compress, my delta V is going to be less than 0 because when we compress, this is what occurs. If my delta V is less than 0, that means my work is going to be less than 0. Okay, so there's no heat that's being transferred. All we're doing is we're compressing the gas down. Decreasing the volume without transferring energy as heat. And increase of pressure increases the internal energy. Okay, so what we're going to do is we're going to increase the pressure. We're going to shrink this down. We are going to increase our delta U. Once again, this is smaller than 0. This is less than 0. This is 0. Delta U equals Q minus W. If my W is less than 0 because I'm decompressing it down, my work is going to be less than 0, which means it's going to be negative. This is 0, so my delta U is going to equal minus a negative, which means we're going to have a positive delta U. So we have a positive delta U. So we vaporize or we compress this, decreasing the volume without transferring any heat. An increase of pressure increases the internal energy. Hot vapor is removed through coils to the exterior of your refrigerator. Oh boy. And heat is naturally removed. Typically this occurs at the bottom of the fridge. Hot to cold, turning vapor back into a liquid. Okay? When you have your refrigerator and it kicks on, okay, that motor starts running in the middle of winter, or it just starts running. If you feel along the bottom, there's usually a vent at the bottom. What it is doing is taking heat and kicking it out into the environment. That's typically where cats and dogs like to lie also in the wintertime, because there's heat that's coming out of the refrigerator. Or if you're standing there and you don't have any socks on, you got bare feet, you warm your feet up a little bit, okay, because there's heat coming out the bottom of the refrigerator. Okay, so vapor, the heat is leaving the vapor. Well, if I start to remove the heat from the vapor, what's going to happen? Well, it's going to decreasing temperature. My delta U is going to decrease. My temperature is going to decrease, which means it's going to then turn back into a liquid. Okay, so my delta U is going to decrease, my heat's going to decrease, my temperature will decrease, and this is a natural, once again, natural flow, because you have all this heat built up that if you feel down at the bottom where the heat comes out, it's fairly warm, okay, which is warmer than our body temperature, which is going to be at least 100 degrees. Okay, that heat's coming out there, it's warm, okay? Our houses are naturally set, thermostats are set for about 70 degrees or 68 degrees. So once again, the heat's going to naturally leave the refrigerator and move back into the environment. And once again, once this liquid has heat removed from it, it cools. When it cools, the vapor goes back into a liquid. Once again, natural means no work is being done. If this is a natural flow, you don't have to do any work when it is a natural flow. When you go from hot to cold, you don't have to do any work to it. Liquid travels an expansion valve, which depressurizes it without absorbing any heat and starts the cycle all over again. So it goes in and decompresses or depressurizes, don't absorb any heat, and then it goes back up and cycles through the refrigerator again and starts the cycle all over again. Once again, Q is equal to 0, your work is greater than 0 because your volume, if I'm depressurizing, that means I have a change of volume that is a positive. If that is a change of volume that is positive, that means my work is going to be positive. And once again, delta U equals Q minus W. If this is positive, that means my internal energy will decrease because this is going to be 0 and I have a positive work here, so my delta U would be negative. Cyclic process, my delta U ends up being 0. Once again, it's very isothermic. Steps will have certain steps. As you go along, your delta U will increase or decrease. Okay? Your temperature increases or decreases as you go through certain steps. But eventually, if you look at the beginning of the process and the end of the process, this delta U ends up being 0 because it starts out at a certain temperature and comes back as a certain temperature, and we start the process over again. So my work net is equal to my heat net. My delta U is equal to 0. My work done is the difference between the heat entered into and out of a system. My work net is equal to my heat H entering and the heat leaving. My heat leaving, my heat entering is my work net. This is an example of how thermodynamics works with you or for you every day in a refrigerator, because we all have refrigerators in our houses. Okay, we all just sort of expect when I put something in there, it's going to cool down. I have some warm Gatorade bottles or bottles of water, and I put them in the refrigerator and I leave them in there for a while. Okay, they will eventually cool down, and it's the coolant that cools them down. Okay, it's different than putting them in a cooler, because a cooler full of ice, okay, that ice melts, we just dump the water out then at that point. We have no way of reclaiming back into the ice. If we wanted to, we could take that water and refreeze it again and to start that cycle all over again, but we don't do that. We just dump the water out. We water the flowers of the yard with it. So this is what is called a cyclic process. Tomorrow, once again, will be our last day of notes. We'll go over the second law of thermodynamics. The little quizzes that I'm putting at the end will once again act as your homework grade for this section of thermodynamics, this chapter. Next week, I will once again post the test on Tuesday. I will post the test on Tuesday. We use Monday sort of as a review day. I'll post it on Tuesday. It will not be due until Thursday or Wednesday evening. And that will be the last thing that we will cover and deal with in the class. If you have any questions, feel free to ask. Once again, please complete the quizzes over the notes as we've gone through them. That will act as our homework grade. Other than that, I have nothing else for you. Hope things going well for you again. Once again, it's going to get warmer out here. It's very happy. I'm very happy about that. But if you have any questions, once again, feel free to ask. Take care of yourselves, and wish you guys were here, but it's okay. Adios. We'll see y'all. See you tomorrow.